Welcome back, everyone. We're on lesson 1 of N8.3. We're going to talk about exploring ratios, equivalent ratios, and comparing ratios today. We're going to go back to the basics here. Just remember, a ratio is a way of comparing amounts. Let's just do this basic question here. A group of students had a choice of either hamburgers or pizza for lunch. 12 students, 5 chose pizza, 7 chose hamburgers. So they drew the diagrams here for a visual. So the ratio of pizza to hamburgers is 5:7. Just recall that the word to means comparison, and we replace it by a colon sign when we put it in numbers. All right, and the ratio of hamburgers to pizza is 7:5. So just make sure you're putting these numbers in the order of the wording of what they're asking. All right, here it asks, what's the ratio of black fish to red fish? So we'd have 2 black fish, 3 red fish, 1, 2, 3, 4 black fish, 1, 2, 3, 4, 5, 6 red fish. And then if we were putting this into a fraction, it would look like this. Okay, ratio is also written in fractions. And when you write those fractions, what do you actually notice? Or do you notice anything? Hopefully you do. So this tank is double this tank, right? These are actually equivalent fractions, which would mean they're also equivalent ratios. All right, so when you're comparing the two, just keep that in mind. And here's the different types that we're going to talk about throughout this unit. So part to whole, a part of a ratio to a whole, compares one part to the whole group. So for example, we have blue marbles to all. Okay, written as words, which we don't with ratios very often. We want the actual numbers here. So blue marbles to all would be, if you count them up, 6 marbles to 22. So blue compared to all. Make sure you include the blue in there when you're counting. Part to part compares a group to another part of a group. So in other words, example here, orange to purple. So counting them up again, you have 4 orange and 5 purple. Okay, again, make sure you're putting them in the right order of the question. And taking that a step further, we can lump some together here. So if we have blue and green to orange and purple, we would do this. So blue is 6 and green is 7. 2, comparing to orange, which is 4, and purple, which is 5. So this would be a 13:9 ratio comparison. Okay, and I just want to go further here and remind you that this is also can be written as a fraction, all of these. Okay, the first number is your numerator, the second is your denominator, and it can also be written as a percentage now that we've done that whole unit. So we'd take 6 divided by 22 times 100, and that would give us 27%. 4 divided by 5 times 100 is 80%. And 13 divided by 9 times 100 is 1.4%. So what these mean is 27% of all the marbles are blue, 80% of the orange marbles compared to purple marbles, or sorry, 80% are orange marbles compared to purple. And this one, the blue and green marbles compared to the orange and purple are 1.4% larger. And 3 term compares 3 quantity measures in the same units. So we're going to go blue marbles to green marbles to purple marbles, which would be, I know you can't see the picture up there, but blue, I counted these up, would be 6 blue to 7 green to 5 purple. So we can have 3 term ratios. You could probably have even more than that, of course, but this is probably as far as we'll go in our assignment. Okay, this one says match the equivalent ratios. So like the fish one, they can be equal and equivalent. All right, so I'm actually just going to let you peruse this for a quick second. Note that we're comparing ratios to fractions, and the fractions are reduced. Okay, so what that means is, I'm actually going to just show you the answers here so it's a little bit quicker to get through. So 5 over 6 is a fraction, is the same as a ratio of 10 to 12 because these fractions are equivalent. right? What we did to one, we top we did to the bottom to make them equivalent. And then they just wrote it as a ratio. Okay. 1 to 5 is the same as 3 to 15 because when you multiply by 3, both of them, right? 5 halves is the same as 10 fourths. Again, multiply by 2, multiply by 2. 3 quarters is the same as 9 to 12. Multiply by 3, multiply by 3. And 1/10 is the same as 6 to 60. You multiplied by 6. Okay, so just you'll have to go back to sort of remembering equivalent fractions, which now can be changed to equivalent fraction ratios or even equivalent ratios down here. Okay, so if we're going to write this as a fraction, the ratio, it would be 10 over 12. Here we're going to write that ratio as a fraction, 3 over 15. This one as a ratio, 10 to 4. 6 to 8 was done for you. And they wrote it with words, as you can tell here. So there's all these different ways. And this one is a fraction. Let's do 6. Actually, let's do the reduced one. 1 to 10. If we would have put 6 to 60, it would have also been equivalent. Usually we're wanting to get it into reduced terms. So I want you to just be aware of what's happening here. These are written all as ratios. If you're having trouble with that visual, you can, that's a 1, always write it out as a fraction. So this is saying 1 to 9 equals x, which is the unknown. That's the number we want to find, to 18. I can see here we multiply by 2, so I'm going to do the same up here. So this x would equal 2. All right, simple one. Now let's try this next one. I'm going to go 3 over 5 equals 5 over x. Now we're in trouble. Because 3 times what equals 5? Uh-oh. It's a decimal number. So I'm going to show you some cross multiplying, which hopefully you saw in grade 7. If not, this is new. If otherwise, it's a review. Okay, so cross multiplying means you're going to multiply on the angle. Okay, so I'm going to go 3 times x, that unknown variable, equals 5 times 5, which is 25. And now in order to get x by itself, we need to divide by whatever this number is, which in this case is 3. Okay, oops, sorry, that one equals. So we're going to divide this by 3. You plunk that into your calculator, and you're going to get x equals 8.3. Right? 3 divided by 3 is 1. 25 divided by 3 is 8.3. This gets x all alone. That's the variable we want to find, that unknown. And it's 8.3 actually. I'm going to do one more just because these are a little bit different. And I like the cross multiplication method because that's getting us onward to our algebra unit, which will be coming up. So we're going to go 17 over 2 equals x over 3. Again, cross multiply. It doesn't matter where that x is on whatever side of the equal sign. We're just going to do the same thing no matter what or how it's lined up. So we get 17 times 3 is 51. 2 times x is 2x. Now we want that x by itself, so we're going to divide by what's beside it, which is 2, which you do to one side, you do to the other. 2 divided by 2 is 1, so these actually cancel out because we don't actually write 1x, because 1x is x. So we have x equals 51 divided by 2, which is 25.5. Okay, so that's what this variable right here would be. Okay, and then it says in direct proportion. So ratios in direct proportion means that they're equivalent. All right. So what ones here are in direct proportion? So in other words, we've got 5 to 10 equals 1 to 2. Does it? Yes, because 5 divided by 5 is 1. 10 divided by 5 is 2. Again, you have to do the same thing to both. And in this case, it was divided by 5. So that is in direct proportion. 1 to 4 and 4 to 1. So to get 1 to 4, we got to multiply by 4. What we do to one side, we do the other. This one did not multiply by 4, it divided. So this is not in direct proportion. 4 to 12, you have to multiply by 3. 2 to 6, you also multiply by 3, so this one is. 1 to 2, multiply by 2. 2 to 3, we do not multiply by 2. This one is not. 1 to 2, we multiply by 2. 6 to 12, we also multiply by 2. So this one is in direct proportion. And here we have 3 to 9, we multiply by 3. And 1 to 3, we multiply by 3. So this is. Okay? So just make sure you're doing the same thing to get from this number to this number as you are to this number to this number. And that's how it will tell you your direct proportion ratios. Okay, here we go. Rick's comparing 2 recipes for oil and vinegar salad dressing. Recipe A calls for 150 milliliters of vinegar and 250 milliliters of oil. I'm going to write that down right away. Okay, recipe A is 150 milliliters vinegar to 250 milliliters oil. I'm going to leave my units out for now. Recipe B calls for 225 millimeters of oil to 400 milliliters of oil. Sorry, I'll do this as a ratio first. Got ahead of myself. Okay. My next step is to put it into a fraction in case you didn't pick that up. Now, you might think by looking at these, you can figure out which salad dressing will have a stronger vinegar taste. And if you're thinking because this one's bigger, that one will, it will not necessarily. You have to actually find your percentages here. Okay, so remember percent, top divided by bottom times 100. And I've already pre-done that on my calculator, and it comes out to 0.6 repeated. Okay, so if you don't remember, that means it's 6 all the way to infinity. Okay, when I did 225 divided by 400 times 100 on my calculator, I got 0.5 repeated. Okay, so we're comparing 0.6 to 0.5. This is bigger, closer to 1. So this tells me that recipe A, in fact, is the one with a higher concentration of vinegar. All right, so that's what the word problems will look like. Okay, and that's pretty much what the questions are going to look like throughout the assignment. So I wish you well on that, and I'll see you in the next lesson.